the binary representation of a number is the bit pattern. Now these shift operators can only be applied on integers. Can only be applied on integers. These shift operators cannot be applied on real numbers. Now what does this shift operator do? They shift the bit pattern. They shift the bit pattern. Hence the name shift operators. Hence the name shift operators. Now there are two types of shift operators. There are two types of shift operators. Two types. Now where all we can shift the bit pattern? Obviously, either you can shift the bit pattern towards the right or you can shift the bit pattern towards the left. Based on this only, there are two types. The first one is the right shift operator. The first one is the right shift operator. And what is the symbol for right shift? It is 2 greater than, it is right shift. The arrow is pointing towards right. And the second one we have is the left shift operator. Now here the arrow is pointing towards left. Please see here, 2 less than symbol is the left shift operator. Now let us discuss the right shift and the left shift in detail. Let us discuss the right shift operator. This right shift operator shifts the bit pattern towards right. Shifts the bit pattern towards right. Towards right. Now the question comes, sir, how many bit pattern towards the right? And how do we write it? Let's see with the help of an general syntax. Suppose if I write x right shift by k, where x is any integer, where x belongs to an integer set and k also belongs to an integer set. Now if I say x right shift by k, it means shift the bit pattern of x by k places towards right. Shift the bit pattern of x towards right by k places. Now let's take an example and try to understand this. Suppose we write y is equal to 10 right shift 1. That means shift the bit pattern of 10 towards right by 1 places. Now how do we solve it? First we convert 10 to binary. We have already seen how do we convert a decimal number to binary. If you haven't watched the video, please watch the video here. Now convert 10 to binary. We repeatedly divide the number by 2. We say 2 5s are 10, remainder is 0. 2 2s are 4, remainder is 1. 2 1s are 2, remainder is 0. And we write the number from bottom to top. Therefore 10 in binary is nothing but 1 0 1 0 in decimal. 10 in decimal is 1 0 1 0 in binary. Now this is bit 0, bit 1, bit 2, bit 3. Each number in binary representation is called as a bit. Now this bit pattern of 10, we have to push it. We have to push it towards the right. Now if we push it towards the right, what happens? Let's see. Now this is the third bit, second bit, first bit, 0th bit. Now these are the 4 friends sitting on a table, on a bench, and you are pushing it towards the right from this position. What will happen? The 0th bit will fall down. The 0th bit will be lost. The first bit will come at the 0th bit position. The second bit will come at the first bit position. The third bit will come at the second bit position. Now what happens? This 1 will be at the 0th place because they are shifting by 1. This 0 which was at second place will come at the first place. This 1 which was at the third place will come at the second place. Now what about this bit? This will be filled with 0. This will be filled with 0. And this 0 is lost. This 0 is lost. Now this is the answer. We have to convert this answer back to decimal to get what is 10 right shift 1. How do we convert it? We say 1 into 2 square plus 1 into 2 to the power 0, and this is equal to 5, and this is equal to 5. Therefore 10 right shift 1 is equal to 5. Therefore 10 right shift 1 is equal to 5. Let's take the second example. We say 10 right shift 2. 10 right shift 2. That means what? Shift the bit pattern of 10 towards the right by 2 places. Hence, first we write this 10 in binary. Already we have converted it. It is 1 0 1 0. 0th bit, first bit, second bit, third bit. We have to shift it towards the right by 2 places. Towards the right by 2 places. Now when we shift towards the right by 2 places, this third bit will come at the first bit place. This second bit will come at the 0th bit place. And what about these 2 bits? These 2 bits are lost because there is no space. Hence, this 0 will come here, this 1 will come here, and we will place 2 zeros at the bit number 2 and bit number 3. Now we have to convert this number back to decimal. This is equal to 1 into 2 to the power 1, which is equal to 2. Hence 10 right shift 2 is equal to 2. Let's see the third example. Let's say 10 right shift by 3 places towards the RHS. We write 10 again in binary representation. It is 1 0 1 0, 0th bit, first bit, second bit, and third bit. Let's write this again. This is third, second, 1 and 0. Now 3 places towards the right means this third bit will come at the 0th bit. This is 1. And these 3 bits are lost. And what we fill here? We fill 0 over here. And this is equal to 1 into 2 to the power 0, which is equal to 1. Hence 10 right shift 3 is equal to 1. But if I write 10.0 right shift 1, it's an error. Why it's an error? Because 10.0 is an real number or a floating point number, and shift operators cannot be applied on real numbers. It can only be applied on integers. Now if I have to summarize it, what happens? What we have understood, we know that 10 right shift 1 is equal to 5. We have got 10 right shift 1 is equal to 5. Now this 5 we can write it as 10 divided by 2. 10 divided by 2. The next thing, 10 right shift 2, we got the answer as 2. 10 right shift 2 is equal to 2, and we can write it as 10 divided by 4. We know that 10 by 4 is not 2.5, it is 2, because integer by integer is integer in C programming language. Last one, 10 right shift by 3, we got the answer as 1, and we can write it as 10 divided by 8. 10 divided by 8 is 1.25 mathematically, but in C programming language, integer by integer is integer, hence 10 divided by 8 is equal to 1. Now this 2 we can write it as 2 to the power 1. This 4 we can write it as 2 square, and this 8 we can write it as 2 cube. Now please see here, right shift by 1 you got 1, Right shift by 2, we got 2. Right shift by 3, we got 3. Therefore, if I write any number x, now this 10 can be any number x, right shift by k. This k can be 1, 2, 3, 4, 5, 6, anything. This is equal to, now here we have got 10, the first number, this is x divided by 2 to the power k. This is x divided by 2 to the power k. I hope that you have understood this. Now let's take an example and try to understand this. Let's take an example and try to understand this. Suppose we write y is equal to 160, right shift by 4. Will you write the bit pattern and do it? No, we already know this formula. X right shift k is nothing but x, this is 160 divided by 2 to the power 4. Now this is equal to 160 divided by 16, which is equal to 10. Therefore 160 right shift by 4 is equal to 10. Let's take one more example. Suppose we say y is equal to 15 right shift by 2. Now this is equal to 15 divided by 2 to the power 2. This is equal to 15 by 4. And what is 15 by 4? It is not 3.75. Integer by integer is integer. Hence 15 right shift by 2 is equal to 3. This is a very simple way you can compute the right shift. What does the right shift do? It shifts the bit pattern of a number towards the RHS. And what is the general formula? X right shift k is nothing but x divided by 2 to the power k. So this is how the right shift works. Now let us see how does the left shift works. Let us now discuss the left shift. As the name indicates, this left shift shifts the bit pattern on the LHS. Shifts the bit pattern on the LHS left hand side. Now how do we write it? We say x left shift by k places. In right shift we have shifted the bit pattern on the RHS. Here we shift the bit pattern on the LHS. Let's understand this with the help of some examples. Suppose we write 10 left shift by 1 place. Now what we need to do, again we have to convert 10 in binary representation, and we already know that 10 in binary is 10 10, 0th bit, first bit, second bit and the third bit. Now this bit places we have to shift on the LHS by 1 place. This 1010 we can write it as 01010. The value doesn't change. We can add as many number of zeros on the LHS, the bit pattern doesn't change. Now what we are doing it here, we are shifting this bit pattern by 1 place on the LHS, Now what will happen? This 0th bit will come at the first bit place, first bit will come at the second bit place, second bit will come at the third bit place, third bit will come at the fourth bit place, and the fourth bit will be lost. This will be lost. Now if I write this, this is where the 0 comes, this is where 1 comes, this is where 0 comes, this is where 1 comes. And what about this place? We add 0. What about this place? We add 0. Now let us convert this number back to decimal. That will be our final answer. Now this is equal to 1 into 2 to the power 4 plus 1 into 2 to the power 2, and this is equal to 20. Therefore 10 left shift 1 is equal to 20. 10 left shift 1 is equal to 20. Let's see the second example. Suppose we say 10 left shift by 2, and let's see the answer. Now what is 10 in binary? 10 in binary is again 10 10. This already we know it. Now this is 0th bit, first bit, second bit, third bit, and let's add 2 zeros on the LHS. Why 2 zeros? Because you are shifting the bit pattern by 2 places on the LHS. Now if I write the bit pattern, this is 5th bit, 4th, 3rd, 2nd, 1st and 0. Now this is 2 places towards the LHS. 0th bit will come at the 2nd bit place, 1st bit will come at the 3rd bit place, 2nd bit will come at the 4th bit place and 3rd bit will come at the 5th bit place. Now this will become 1, this is 0, this is 1, this is 0, and what about these 2 zeros? These are lost. And what do we fill at these 2 places? We fill 0. Now this number we convert back to the decimal. This is 1 into 2 to the power 5 plus 1 into 2 to the power 3, and this is equal to 40. This is equal to 40. Therefore 10 left shift by 2 is equal to 40. Now we can generalize here as well. We know that 10 left shift 1, we got the answer as 20, and this 20 we can write it as 10 into 2. This 20 we can write it as 10 into 2. 10 left shift 2 is equal to 40, and this 40 we can write it as 10 into 2 square, that is 10 into 4. Here it is 1, therefore I can write it as 10 into 2 to the power 1. Hence, in generalized way, x left shift k is equal to x into 2 to the power k. X into 2 to the power k. Therefore, if we want 10 left shift 3, are we going to write the bit pattern and compute it? There is no need. We can simply apply the formula. This is equal to 10 into 2 to the power 3, which is equal to 80, which is equal to 80. So I hope that you have understood this. Suppose if I write 10.0 left shift by 4, this is an error. This is an error because this is a shift operator, and shift operators can only be applied on integers, but 10.0 is a real number, is a floating point number, and left shift cannot be applied on, or right shift cannot be applied on floating point numbers. So friends, I hope that you have understood both the left shift and the right shift. If you are new to this channel, please subscribe this channel, like this video, share this channel with your friends, comment on the comment section how do you find this video. Thank you friends for watching this. Have a great day.